Hello guys, let's solve today's daily challenge problem, that is house robber 4. The problem states that there is an array given. There are houses, there are homes on a street. On street basically represents a single line, basically an array, and each home has some amount of money. So nums of I will tell me how much money is there on the ith home, in the ith home, and there is also a robber, and robber can steal the money from ith house only if he has not stolen from the neighboring houses of the ith house. Basically, nums of I minus 1 and nums of I plus 1 are the neighboring houses of nums of I. So if those are not stolen, then nums of I can be stolen. Yeah. So there's something called as capability of the robber, which is the maximum amount of money that robber has stolen from a particular house out of all of the houses he has stolen. So let's say let's say here there are four houses. So if he has stolen, let me say two houses, let me say this is second and the fourth house, then the capability for such kind of robbery is 9, because 9 is the maximum among all the money which is present in the houses which are stolen. Okay, so what they have told is this is the capability, and now what they want is they want minimum capability. So they want minimum capability of the robber of all the possible ways he can steal the houses, at least k houses. So there is a condition that at least k houses has to be stolen, and another condition is another query is like out of, let me say he can stole k houses, at least k houses at any way, but they want the capability of the algorithm of stealing the houses such that the capability should be as minimum as possible. So yeah, let's go from to the first example. Here he can stole 2 and 3, the first house and the third house, because those are not neighboring, and then the capability will be maximum of these two, which is 5, and 5 is one of the capability. So the robber can steal either 2 and 5 money, like I can say $2 and $5, or you can steal $3 and $9. So the capability here is 5, because 5, like, capability is the maximum amount of money he steals among all the money he steals, and in this part the capability is 9, and out of these all the capabilities they want the minimum. So minimum of these both is 5. So 5 is the answer over here. Okay, so let's come to the solution. So when you see something which they have asked as a minimum or maximum, the first thing which has to come to mind is binary search. So because if they've asked minimum, we know that minimum capability is the maximum money which he has stolen out of one procedure. So if we cap the money he can steal to some value, we can easily find out that if there are at least k houses which can be stolen. So I'll do binary search on capability value. So let me say my binary search current max possible value is 10. So can I steal at least 2 houses? It's yeah, I can steal 2, then I should ignore the neighbor, I should go to next, I can steal 5, and 2 is completed. So 2 and 5 both are less than 10, so it was possible. So number of houses stolen is 2, which is possible. Let me reduce this to half. So 10 by 2 is half, I mean 5. So robbery of at least 2 houses is still possible. I can rob the first house, then I can ignore the neighbor, then I can rob the fifth house. So 2 and 5 are robbed, like 2 and 5 money are stolen, so both of them are less than or equals to 5, so this is also possible. So I should like keep a track of max and minimum. So 0, like max he can store is minimum of all this, which is minimum of the houses, minimum money which each house has, and max is the max value of the money which one of the houses among all has. Let me say it is 10, or I can even take it as 9. Let me say if it is 10, as I already proceeded. So now my area of search would be in the range 2, 5. Now let me say 5 is possible. I'll reduce the upper bound again, dividing by 2, so it will be 2. Is it possible that I can steal at least 2 houses with max capability being 2? No, it's not, because only one house is robbery is possible. All others are greater than 2. So I should revert this, and I need to increase this up by 2 times. I mean 2 times is 4. So mid will be again 4. So is it possible that I can steal with 4 as the capability? I can steal 2. Further, I can't steal 3. I can steal, if I don't steal 5, then there are no possibilities. So if I steal 5, then capability will be exceeding 4. What if I start with 3? If I start with 3, I can steal 3. I can further steal 9. So capability is 9. So in both cases this is not possible. So 4 can't be the answer. Now this has to be incremented. So at the end we got what is the optimal minimum capability. That's how a binary search works. Let me just explain through the code once fastly. So this is our code. So first of all, what I have taken is minimum element, because capability can't be lesser than the minimum element and capability can't be more than the maximum element. For the binary search, I have assigned them as min and max as are high and low capability values. Also now I will compute the mid, and I will check if this is possible. If it is possible, then I want to reduce the capability. So because they have asked minimum capability, so I will do this high as mid minus 1, because we know mid is already possible. We just do high as mid minus 1, and then if it is not possible, then we need to increment like our capability range. So it will be mid plus 2, and at the end how we choose is possible is we'll take the nums, we'll pass k2, and max will be the mid value over here. So max amount of money which can be stolen from any of the houses, max permissible amount is this value. So if we iterate over the array, we check if we just proceed forward until we find a house which has less money, less than or equals to max value of money. So if it is, if such house is found, then we increment the number of house taken, in a sense number of house stolen, and then we just return if it is matching k, because if we are stealing k houses, then I am directly breaking out of the loop. So for this capability to be possible, it should match, at least k houses should be robbed as given in the question. So yeah, this will derive the binary search, and at the end we just return the capability which is possible. So yeah, this is how it works, and I hope you understood the explanation. Thanks.